Welcome everybody. This is the second of 3 webinars to do with the Proteus, provided by Proteus Instruments, and today we have one of our distributors, Nighthouse Industries, that are also going to be presenting. So without further ado, just to let you know that everything will be recorded, so we will be able to make this video available after the presentation, just as we have done with the first one. There is a chat, so by all means, if you would like to raise any questions, make any points, feel free. We will endeavour with the team to answer as many of the questions as possible within the actual webinar itself. But there will also be a Q&A at the end, and we will also capture all those questions and answers and publish them after the webinar as well. So without further ado, we'll get started. So just really quickly, an agenda for today. As I said, the webinar will be recorded and a link will be sent out afterwards. It is a little bit different with LinkedIn, so we're not able to capture email addresses and what have you, but we will make the video available. So in terms of sort of an introduction, we're going to start off with Hannah, who will provide a background to the sort of the UK, the legislative backdrop to monitoring in our bathing waters, and then as Hannah will then go on to explain a little bit about the science and how Proteus works. We're then going to move on to some application stories. So the first of which will be about a project with Southern Water, which is really sort of heralded as a potential blueprint for monitoring our bathing waters here in the UK. We're then going to do another application story with Nijhuis, who have been using the Proteus for bathing water investigations. And thirdly, we're just going to end up with some sort of ideas about inland bathing waters. Although very new to the UK and we've only got a couple, it is obviously going to be a significant area of focus over the next 5 to 10 years. And then we'll end up with a Q&A discussion where we will stay to the end and answer all your questions. So a little bit about who's presenting is obviously myself. I'm a director at Proteus Instruments. I've sort of been in the industry for more years than I care to remember. So hopefully that will help us all along today. We then have Hannah, who's currently undertaking a PhD into low-range coliform measurement. And lastly, we have Andy and Jack from Nighthouse. Andy is a senior scientist, and Jack Jones is the Innovation and Sustainability Manager for Nighthouse. So just to give you a little background about Proteus, we are very much a classic story of innovation. We started way back in 2013 as we started a project known as a knowledge transfer partnership, which is between our mother company, RS Hydro, and the University of Birmingham. That lasted about 2.5 years, and the whole idea was to embed a prototype and develop it into a real instrument, which, with a couple of extra years worth of research, we managed to do by 2018. At which point we then launched it at probably one of the world's largest water and wastewater shows, which is IFAT in Munich. It was a massive success, and we now can claim that we're the only instrument in the world that can measure these organic parameters in real time. A year later, we launched H2 Now Chicago. So this is run by an organisation called Current Water, and it's now the world's first real-time coliform monitoring platform in the world. Another year later, 2020, we started we won a project on the River Ganges with our partners in India, Swan Environmental, which was for the installation of 40 real-time Proteus units right from the mountains right down to Bangladesh. And we also, within those 2 years, have now appointed 25 distributors. A year later, we won the Institute of Water National Innovation Award. We won a large project for Scottish Water, and we've moved premises, and we now have over 40 distributors. And to cap it all off, this year, literally a week or so ago, we won the Queen's Award for Enterprise in the Innovation classification. So that's just a little bit about us. I'm now going to hand you over to Hannah, who's going to, there you go, provide you some background on what the Proteus is. Over to you, Hannah.
Thanks, Rob. So we're going to start with just how the Proteus works and the science powering behind it. Apologies, I think I accidentally muted myself there. Yes, so Proteus and the science powering the probe. The Proteus multi-probe has been designed as a multi-parameter water quality monitoring platform that really uses fluorescence technology at the heart of it. So we have targeted wavelength fluorometers that we combine with other water quality parameters like temperature and turbidity to create a platform overall that can sort of do everything. So our most common fluorometers that we have are tryptophan-like fluorescence and CDOM, which is chromophoric dissolved organic matter. And those are the two we work with the most, but the whole range includes oils, chlorophylls, rhodamine, and other bits and pieces. Where Proteus goes one step further is it doesn't stop with just giving you a raw fluorescence output. It takes the fluorescence output, combines it with some other parameters like temperature and turbidity, and then uses site-specific or global calibration coefficients to output other parameters such as BOD and COD, various varieties of coliforms, and things like total organic carbon. So at the heart of this, we sort of have to say, take it back a step, and what is fluorescence? So fluorescence is one of the components that makes up what we call luminescence, which would be the emission of light from a substance when it's originating from an electronically excited state. So what we're talking about here is we're talking about intrinsic fluorophores. So these are molecules or macromolecules that fluoresce without you having to add anything to them. It's a reagentless process because there's something about the molecule naturally that allows this process to take place. And quite a few of you might actually be know more about fluorophores than you think you do if you enjoy a gin and tonic in the evening, because one of the very common fluorophores is quinine, which of course you will find in tonic water. Other common ones that we work with are things like tryptophan, but also tyrosine and things like fluorescein, also intrinsic fluorophores. So we've been aware of particular fluorophores at particular wavelengths for quite a while, but it took time for the technology to be taken out of a laboratory setting and then be moved into a field setting, which is sort of where we're coming up to now. So just a bit on how fluorescence actually occurs. When we talk about fluorescence, we talk about excitation and emission. So in order for fluorescence to occur, you have to first excite the molecule that you're targeting. And you do this by exciting it with a photon, so you fire light at it at a particular wavelength. The electrons in the molecule will then raise their energy level. They go into what we call an excited state in response to the excitation light. And this cannot be sustained indefinitely. Eventually, you'll turn the light off and it has to go back down to its ground state. And when fluorescence occurs, it's because the pathway chosen is the emission of a photon. Fluorescence is not the only way to get electrons back down. There's multiple pathways that compete that are radiative and non-radiative. We're obviously interested in fluorescence, but that's something to bear in mind when we actually do the work. Is there anything that's going to potentially swap the pathway over and make a more efficient way to lose the energy? And one of the things we do at Proteus is temperature compensation, because temperature will affect how the molecule reacts, and we have inbuilt temperature compensation to deal with exactly that. So just a little bit more on sort of my side of things. I'm mostly interested in tryptophan-like fluorescence because I'm interested in the relationship to E. coli and looking at potable water. But when we start with sort of tryptophan in general, we've got in the bottom right-hand corner is our tryptophan molecule, and the little indole group on the end that's with the arrow is the bit that causes it to fluoresce. And this sort of brings me to the important point that we talked about, tryptophan-like fluorescence. So we identify this kind of protein-like fluorescence by using tryptophan as the marker, but there are other compounds and molecules that will also fluoresce in the same wavelength, which is important when it comes to cleaning up signals. Tryptophan is a dual peaking fluorophore. So if you look at this big EAM at the top, which shows the excitation wavelengths, the emission wavelengths, and then the intensity, you see tryptophan peak T has 2 peaks, of which the peak that's been most strongly associated with living and dead organisms and their fecal matter is the one that excites at around 270, 280, and then emits 350, 360. And that, in a nutshell, is fluorescence. I was going to say the last diagram on there is a molecule of E. coli itself, and its lovely little peaks on the variant. But what we do specifically with the targeted wavelength fluorometers is, instead of scanning all the ranges like we do with this EAM, we go in on ones very specifically because we're looking for exactly what's there. So what's this all got to do with bathing water quality? So bathing water quality in the UK is quite an interesting setup. So the UK as a whole has over 600 what we call designated bathing waters. So these have been specifically set up to be monitored so that we can know if they're safe to bathe in or not, which comes out with weekly sampling from, in England, it's May 15th to September 30th. And the 2 things they're always looking at for is E. coli and intestinal enterococci, because they are fecal indicator bacteria, and they will give a very strong indication of whether or not there's been a large amount of fecal pollution into the water, and therefore how safe it is to swim in. We classify this into 4 categories. Excellent, good, and sufficient are all passes. Poor is the failed category, and if something comes back as poor, you put a advice against bathing notice on it. It doesn't mean that it's illegal to bathe in it or that the beach will be shut. It's just that it's a way of letting the public know high chance that you might get sick or being exposed to some sort of risk. And I should say these are threshold categories. So for both E. coli and intestinal enterococci in these categories, you've got a range within which the coliform counts must form. So with that in mind, I just have a very quick overview of the location of all the UK's bathing waters. So obviously England, Wales, Northern Ireland and Scotland. And you can view this data online, and there is another service which we'll get to in a minute. And it's quite interesting to look at the way they're spread because they're overwhelmingly coastal, and there are only a few that are actually located inland. So with that in mind, how effective are they? So when we first started dealing with a designated bathing water status in the 1970s, granted there were many less than there are now, just under half of them were classified as poor. Where we are in 2022, so in England's bathing waters specifically, around 95% of them at the moment are meeting acceptable water quality standards. So we touched on coastal locations. Only a few bathing waters are inland, and we only actually have 1 river-based bathing water at the moment. Most of them, the inland, are not river-based. And that's interesting because the pollution source, when we're looking at bathing waters on the coast, can be coastal, but it can equally be coming down a river. So it's sort of how we're looking at the way we're monitoring pollution. Also, we've got a big growing popularity in the UK of wild swimming, stand-up paddleboarding, those kinds of water sports being sort of much more accessible. And a lot of the time they are happening inland. It's where people don't have access to the coast. So one of the great things that you can have is the Safer Sea service run by the Surfers Against Sewage, which is joint effort by them and the water companies. So it's a real-time map that when a CSO, combined sewer overflow, is about to activate for whatever reason, the company will inform the Safer Sea service, and they can put an alert out on their map, and it can text you and put a push notification through to your phone, so you know instantly whether or not the water is safe to go into or not, which is a really good tool to have, because prior to this there's only the government, the information that's released by DEFRA, which is a bit harder to access in sort of a mobile format. Looking at water quality improvements, as I've already sort of said, since this all began, we have improved water quality. So a big thing about this is when you get a poor bathing water or one that's just sufficient, it can be a trigger point to trying to then improve water quality by setting targets and cleaning up, especially when there's like a tourism aspect that's playing a role as well. Equally, During the pandemic, there was a monitoring blackout because of all the rules and restrictions in place, and this relies on manual sampling. So people have to go and physically do it. They have to take it to the lab, wait for the results. Not the greatest thing in the world. And also looking at the fact that there's no monitoring during winter. Well, there's some monitoring in some places, but it's not regular or specific. And in the UK, I've done a lot of research recently on wild swimming, and lots of people love wild swimming in winter when it's freezing. And they necessarily don't have the same quality of data to look for in the winter. So where we sort of are now and looking to the future, in December 2020, we got, like I said, the first river designated bathing water in Yorkshire for one section of river. It's also the Environment Act that went through Parliament last year is looking at increasing monitoring requirements, and complying with that and the general interest in inland water bathing at the moment may result in more sections of river being designated soon. And that's potentially interesting when you just take a step back and looking at all of it and think about, okay, well, what's the motivation here? Why are we monitoring bathing waters in the way we are? How do we decide on the parameters we're using? Is that first and foremost, river and seas are not really meant for human bathing in general. They're supporting ecosystems and weather systems and all sorts of other things. So sort of as a point to leave this and lead on to the rest of the presentation, it's quite interesting to think about how we monitor and how we might mitigate where we get results we don't like, and to what extent we should be doing that. But that is pretty much all from me.
Okay, thanks, Hannah. Right, so we're now at a stage where we're going to talk about a number of application stories. The first of which is a pilot for specifically for Southern Water, but it's actually for the UK as a whole in many respects. So what we're going to do is going to walk you through progress to date, a bit of background behind the project as well. So to sort of recap, really, I mean, in the UK, you can see here by this diagram that we don't fare very well when it comes to water quality status. And unfortunately, we share the sort of bottom with some of the poorer countries of Europe, which is a real shame, specifically for our rivers. So there is a real history or a lack of investment in the UK to improve our water quality. We've all seen adverts, news articles in various different papers. They happen more or less every day, and it's usually about the scale and sheer quantity of pollution events and how many times CSOs have discharged. So I'm not going to dwell on that, but it's obviously happening all around us. In terms of current practice, the sort of main sources of information, you have SWIMFO as by the Environment Agency, which monitors about 420 locations, and last year they took 7,000 samples. So that is a massive undertaking by Environment Agency staff to sort of get all those samples and get them all analysed. But this only happens between the 15th of May and 30th of September, so it's only for a few months. That data looks much like what Hannah's already shown you. You can go onto the Environment Agency or the government website and you can see the current status, and you can drill into it and see what the readings were. But you probably can see where my mouse is. All these little blue dots are individual samples. So for last year, I'm not sure when this was actually captured, but you can see typically there's about 2 in May and 4 or 5 or 4 in June there. So they're not that, it's only about once a week at best. So it's not got an awful lot of detail. And then we have the Surfers Against Sewage app, which is a brilliant app. But like so many of these, including Rivers Trust as well, there's no scale of impact. And it does rely on the event duration monitor data to be accurate. So that data looks a bit like this. So you get a nice tick where it's okay and a cross where it's not. And you can have those notifications sent to your phone. Obviously, this all for the bathing waters relies on manual samples, and can be up to a 7-day lag to report them and get the data where it needs to be. In the last couple of years, we've had obviously issues with COVID, and at one point sampling was very much restricted. As I said, the bathing sample was very small, but what about the winter and autumn months, where wild swimming happens all year round, believe it or not? I know there's even a Christmas Day swim or something like that in Brighton, so you know there is a need for more regular monitoring, and based on one sample a week, that's not going to provide the sort of the safety net we want. But what we do need to do is be able to share this data more freely and quickly. There's also a significant cost and a potential accuracy over manual sampling. Manual sampling is quite a simple procedure in some respects, but it's also extremely easy to get it wrong. It's not real time, so we can't make informed decisions about whether to use bathing waters or rivers for swimming. And how do you effectively alert the recreational user to say it's safe? Just because an EDM is triggered does not mean that the river is polluted, or indeed the bathing water is polluted. It obviously just indicates that a CSO has spilled. So unfortunately, if it all goes wrong, you end up with a sign like this, where it's just manually stuck on a pole on a particular beach. But the problem for bathers is that they have to rely on signs like this, and obviously the apps from the SAS and Swimfo, or indeed word of mouth, or if it all goes wrong, you find out the hard way. And I think everyone's probably got a story where they've been swimming somewhere and not felt well the next day. And it's not really the best approach to decide whether you want to swim somewhere or not safely. So the problem really highlights the issue that the signs and boards report the problem after it's happened. So that big sign there is because at some point in the previous 7 days there has been a problem. It would not have been up at the time of the problem. So we've mentioned how accurate it is. There's issues, silly little things like vandalism. Someone could just remove the sign, turn it round, and someone wouldn't be aware. Next thing you know, someone's ill. It does rely on manual deployment. And the other side of things is that it does create animosity and bad press. There's no reason to publicise this unless there is an issue, and the signs should only be up for as long as they're needed. So if we just move on to Southern Water, and obviously all the water companies have a similar issue in their territory, but Southern Water have moved quite quickly on this as the technology has been released. So this is just going to give you a bit of a backdrop really for that. Currently they use something similar. It's a web page. They call it Beach Boy, and it gives you a map showing you the status of the CSOs and the spill data and the actual specific spill start times and end times and durations, along with all the locational data there. That was just grabbed a couple of days ago. As you can see, there are a couple here which are obviously in alert. So again, it doesn't include any information about water quality. It doesn't mean it's polluted. It just means the CSO has spilled. There is obviously a tangible link between a spill and pollution in most cases, but not always. And obviously the details are there. Unfortunately, we can end up with scenes like this, and this is what we're all keen to avoid. So a collaborative project has been put together by Southern Water, who are paying for it all, together with ourselves, the Environment Agency and the local borough council. We're going to talk about one specific location, but there are actually 4 in process at the moment. So the one I'm going to talk about is Hayling Island. There was when it was released in the press, probably about 4 or 5 weeks ago, there was a lot of coverage about this. And in effect, is basically a water quality buoy, which will be located off the beach to provide real-time alerts. In terms of location, so for people overseas, if you want to know where it is, it's just here to the south of England, and it's just across the way from the Isle of Wight on Hayling Island. This is an aerial view of the beach, and you can see it's a very popular, looks like there's a big sailing regatta going on at that point. Yeah, the buoy is effectively going to be located off the beach here. What is that going to involve? Well, it's going to have a pretty significant data buoy, which is one of these, will be anchored to the seabed with a weight, and it's solar powered with a marker light, obviously for boats to be aware of it. And the actual Proteus will be installed here in the cage, connected up to here to a data logger, battery, telemetry unit, and the solar panels. It's actually ready to go. We're just waiting for some permits to be able to install it. So the whole idea is that it will be live this summer. But as you can see here, we have a Proteus, which is mounted here. All the sensors are down here behind this guard, and there is a cable that runs up to the data buoy itself. Pretty pioneering. So this particular one is going to have BOD, total coliforms, E. coli, turbidity, pH, and ORP, as well as conductivity, salinity, CDOM, and temperature. It will provide real-time data. There will be some verification sampling going on in the background, because everyone needs to be happy that it's working. But obviously, once it's deployed and running, there is going to be minimal costs associated with running this type of platform. It will provide instantaneous alerts as to whether there are any problems, and there is potential to be able to share the data, potentially with API or web links or what have you, so that multiple users can actually see the data. What will that data look like? Well, it's probably just to give you a bit of an idea. This is actually an app which has been made by one of our distributors in the Philippines for a number of data buoys they have, and you can see that in effect you'll be able to just scroll up and down or drill into the data. You could have it in a different way. This is actually a bathing water area in the UK, and on this particular one, with it being actually a freshwater one, is that we've actually put the bathing water classification index on there. So we have green for excellent, white for good, and red for poor. And this was a period, it was installed for quite a while. This was a period where there were significant events going on. This is just really a calibration data. So you can see how accurate the sensors are. What's also happened to the ability of the platform is that you can actually overlay the actual lab samples over it, so you can actually see where they fall. So launch date is going to be this summer. As I said, the instruments are ready to deploy. We're literally waiting for the permit, and once that's done, it will be deployed. So all I can say is watch this space on this one. Very exciting. So obviously it's the first for the UK, so we'll keep you posted. Now I'm going to move on to our next presentation, which is from Nijhuis, and I'm just going to hand over to Jack Jones, who's the Innovation and Sustainability Manager. And between Jack and Andy, they'll talk you through this next presentation. Thanks, guys.
Brilliant. Thanks, Rob. Good afternoon, everyone. Thanks for joining, and thanks to everyone at Proteus for inviting us to speak this afternoon. Yeah, as Rob said, I'm Jack Jones, and I'm joined by Andy Fitzgerald, who's our principal scientist. we just wanted to talk you through some of the ways that we've used the Proteus over the past couple of years, some of the learnings that we've had from it. I'll start by giving just a very brief introduction to Nighthouse Saw Industries, what we do here in the UK, and then I'll hand over to Andy to talk in a bit more detail about how we've used the Proteus for triaging samples to evaluate which samples need to be sent to the lab to minimise lab use, the tracer surveys that we've used the Proteus for, as well as catchment surveys, and I'll do a very brief touch on to inline bathing waters, which I think Rob's going to talk about in a little bit more detail. So by way of a quick introduction to Nighthouse Saw Industries, we're part of the SAW group, and we make up the Industrial Water Solutions division. Here in the UK, we are heavily involved with municipal water and wastewater treatment as well, and we, our mission is Mission Water, and we have a broad range of brands and technologies under the Nighthouse Saw Industries umbrella, able to really treat a wide range of water and wastewater. We're a growing organisation, and we're really focused on sustainable and resilient water use, energy and resource recovery solutions and services. Now, we're known as an OEM and a hardware company, but here in the UK we also have a real strong focus on service provision. And I'm just trying to click onto the next slide, which will tell you a little bit more about Nijhuis Scientific Services. So Nijhuis Scientific Services is the scientific services division of Nijhuis here in the UK. Some of you may recognise the name Aquatic Water Services, which was the company that Nijhuis acquired in 2017 that became Nijhuis Scientific Services. Now we have a team of engineers, technicians and scientists. Some of them are pictured here, nicely socially distanced, but it's quite a substantially larger team than that now, and they're really focused on gathering data to inform environmental decisions and inform designs for water and wastewater treatment plants. So we do things like flow and load surveys, we do environmental and oceanographic surveys. We have a lab down in Truro where we do treatability studies and lab trials, and we do process investigation and optimization. And a lot of the work that we do in the southwest has been focused on bathing water and shellfish water investigations, which is really where the Proteus we've used most over the last couple of years. And we've also been involved in the COVID surveillance sampling and chemical investigation programme. So we've been using the Proteus a lot over the last year or so, had some really good experience with it. And Andy, our principal scientist, is now going to run you through some of the applications that we've used it for.
Thank you, Jack. As Jack was outlining, in terms of the bathing water investigations, our needs are a little bit different from live monitoring of E. coli. We're very much trying to look at the sort of sources of contamination and really understanding those background processes, either hydrologically or oceanographically. So I say MST triage, ironically, was pretty well brought around because of COVID, because the microbial source tracking work, which normally is done as part of bathing water investigations, the labs, because of COVID, couldn't do the molecular work at the time. This is very expensive testing. Is basically, sorry, I'm struggling to get control. I'm not getting advancing of the screens there. Rob, could you release us? Because I'm not advancing. There we go. Okay, thank you. So really what we're looking for microbial source tracking is to identify other sources of E. coli. So there's a nice bird pooping in the background there, but it's really to try and identify things going on beyond just human contamination. So again, we'll do lots of sampling for thousands of samples from dozens of sites where we do E. coli and intestinal enterococci. But this testing, the molecular testing, is very, very expensive. And because it's obviously quite difficult to do and needs to be done rapidly, we needed a means to rapidly screen samples, hence the triage. So we have samples that are, I'm still not getting control here. So we have a number of samples that we're just I can't advance here. There we go. Here we are. I'm here. A number of samples that we're doing laboratory work for. We can screen those samples and rapidly use Proteus to cherry pick those samples to go on for filtering for MST analysis at a later stage. So I'd say we had quite a good relationship between the lab E. coli and the Proteus output, and it was very effective at cherry picking that top percentile of samples. So highly successful in cherry picking those most contaminated samples, the ones in red that you can see there, and we were able to filter those samples. And we didn't have a sort of false negative until we were in the top sort of 30th percentile. So very effective at highlighting those points which are most contaminated. Okay, I'm just trying to advance, but I'm still not advancing. Okay, so some of the other catchments we didn't have such a good relationship with, and it was only really when we looking at some of the parameters, other parameters like conductivity and CDOM, you can see how different the water body is in terms of variation of those other parameters, and it became apparent that if you wanted to really look at a range of quality issues, when you look at CDOM and tryptophan, you can see the clusters, individual subsites within catchments had very different characteristics. And because of that, it became apparent that whilst you can get some really useful information, if you wanted to really understand what was going on, it was possible to use those other parameters to best try and hone site-specific calibrated algorithms, which is something that Hannah talked about earlier. So that's where we left off with it, that it's a useful screening tool, but it's also can be honed on a site-specific basis. So looking at some of the tracer applications now, we're looking a little bit at impact of rivers on bathing waters and outfalls on bathing waters. So the first case study here was a drogue study where you deploy sails within the water and see where they track. And this was off the mouth of a river and trying to look at the impacts on a beach. But for us, it was an ideal opportunity to potentially use Proteus as a tool just to see what that might mean in terms of quality. So we did spot samples at this point. So we were actually taking samples as we were taking fixes on the drogue, and we could actually see how the quality measured up. There were issues with regards to use of buckets and plastic buckets and stainless steel buckets. So some of the tryptophan figures were interesting, but what we found that when we used some of the other parameters like CDOM and salinity, we could see for the 4 survey dates we had, you can see for the 4 different colors there, we have very different signatures. And as conservative contaminants, you know, the CDOM and the salinity, you can see as the mixing with the seawater, the river water, you had these very distinct signatures for each of the 4 days. But most interesting, when you look at the orange one, when we came inshore and took some fixes closer to the beach, we could pick up a discrete signal for the other water sources with a very different profile. So again, as a tool, beyond looking at tryptophan, it's fantastic to have those other parameters to try and characterize different water bodies. Okay. This next one is an outfall study. So this was using qualitative dye releases, fluorescein releases, fluorescent fluorescein to mark wastewater and time tag it so that you could see certain discrete periods of time where the water and the plume, where it moved and how it might impact on the beach. For us, it was an opportunity to try and deploy the Proteus. So we basically had a system that we deployed off the beam of a boat that we could tow around. And we had this as an example of some of the time series here. Some lovely peaks in terms of both tryptophan, but we also noticed that we had this CDOM peak whenever we were going through the dye. So the CDOM was actually picking up the dye. And when we looked at it a little bit more, this is a vessel track and try and differentiate the CDOM from the tryptophan, it became apparent that the fluorescein was actually depressing the tryptophan signal and giving us the CDOM signal, and that the tryptophan, high tryptophan that we were finding outside the dye was actually the wastewater plume that wasn't marked by the dye. So it sort of highlighted in a way that this was quite a useful tool for being able to monitor wastewater plumes without the use of dye. So particularly if you're in some bathing water areas where aesthetically, these high amenity beaches, they tend to be a little bit twitchy about you chucking in dye, especially when it goes in on the beach. So to be able to track a plume invisibly using a tool is quite useful in terms of our clients. So I'm going to go and talk a little bit now about catchment studies, and we had some work here where we're looking at dry weather, detection of hotspots, but also some storm events. So we were looking at an agricultural catchment with potential impacts on a bathing water, and we had flow meters and rain gauges deployed, but we were only monitoring 2 points at the bottom of each of these subcatchments. And we were conscious that there was a lot going on in the catchment that we might be completely missing with our very limited budget for laboratory samples. So the Proteus was a fantastic tool to be able to walk over. So we were there looking at agricultural land use, particularly where sludge and slurry was applied to the land, and they were looking at E. coli and nutrient and solids runoff associated with land use. So for us, it was really interesting to be able to go and do walkovers, and you can see these series of plots here. On the right hand, sorry, on the left hand side, you can see the northern subcatchment, some of the data points from there in terms of various parameters, and then in the centre, there's a southern subcatchment, and then the combined catchment. Now, if we'd have just done the standard bottom of the catchment sampling, we'd have completely missed all the detail and the hotspots that were going on right up in the tiny little tributaries. So it was a really useful tool to be able to see some of these hotspots and catch them in a way that we wouldn't have been able to do with the standard lab analysis. When it came to the storm profiling, we deployed autosamplers with bottler carousels based on a forecast. And these plots really show the individual samples for the 24 hours over a storm event. It's quite a small catchment, so they're quite spiky little events. But you can see that we use the Proteus effectively to cherry pick samples, because what we have is a large number of samples which we need to rapidly screen so that we can pick those high samples to be submitted to the lab, all within the time constraints of getting E. coli to the lab. So what you need to be able to do with this is not only target your budget to make the most use of the laboratory analysis that you've got, but you need to be able to make these decisions very time effectively. So Proteus can be a really good tool for making those decisions rapidly. That's it. Right, Jack, if you'd like to take over just to finish off. Thank you.
Thanks, Andy. Yeah, that's great. You can go on to the next slide if you like. But yeah, I just wanted to really briefly touch on inland bathing waters, which Hannah and Rob have already talked about. As Andy said, we've developed some really good methodologies for using the Proteus for screening samples, building up a really good understanding of catchments, and for river and outfall tracer surveys. And one of the other applications that we can see the Proteus will be really useful for is for inland bathing water surveying and for long-term monitoring. So that's something we're beginning to look into, and yeah, looking forward to developing that in the future. I think Rob's going to take back over now, and
that's great.
A little detail.
Thanks very much, Jack. Where is that pirate ship, by the way?
That is River Dart Country Park.
Oh, blimey. I used to go there as a kid. Okay, right.
Yeah,
I missed that though, so that must be a recent one. Okay, great stuff. Thanks very much for that. Really, really interesting. It's great to see some, obviously some analytical perspectives in that. So yeah, I look forward to working with you more on those in the future. So I think really that this webinar probably wouldn't be complete without just touching upon inland bathing waters as well. We've not done a big section on it, but I think it would be good because it's going to be very topical over the next 5 to 10 years. And so we've just put a few ideas and notes together to share with you. So firstly, in the UK, we fall a long way behind Europe for designated bathing waters, especially for inland. We currently have 2, with the most recent one at Port Meadow, and obviously the one up at Ilkley. But the main issue that I suppose I personally have, and it is my viewpoint, is that a bathing water is fantastic, and if you have a lot of bathing waters, brilliant. But the thing is, as I say there, it's like protecting one small artery in your body. You know, just because you look after that doesn't mean the rest of your body's going to be okay. So there needs to be very much a holistic approach to protecting the whole of the river, in order to make sure that bathing water is okay. And I know a lot of water companies are working towards that, but until that happens, like we're seeing with the Wharf and other bathing waters, it doesn't mean that they're going to be have excellent water quality just because they've got status. So the other thing is that, especially in rivers more than the coastal areas, a single sample a week is not really going to be at a level which is going to keep up with the rapid changes in water quality that you may see in a river. So it definitely needs a lot more rapid monitoring than that. Here in the UK, we don't have any monitored bathing waters, really, so it's not possible to show you an example. However, we have done the equivalent in the US, and this was the first in Chicago. We actually put them in 2019, but it was actually officially launched by Current Water last year. The delay was due to COVID, as you can probably imagine. But the whole idea of the platform is to sort of reconnect the local people with the river so that they can use it and know when they can use it and stay safe and well at the same time. But if anyone's probably not, but there is a huge report by the World Bank in 2019, which basically summarizes by saying that development in all around the world is inextricably linked to water quality in rivers. If you have poor water quality in rivers, then investment and growth in those areas is going to be restricted. So it's really important to protect these rivers. So Chicago are doing exactly this. So they have released the first, it is the world's first real-time platform for measuring coliforms, and they are sharing the data with a whole range of users. There's even talk that it will actually be appended to the local weather forecast as well. So it's an interesting story. Very briefly, Chicago being here, this is Lake Michigan. Originally, back over 100 years ago, there was a north branch and a south branch that fed down to the main stem, which was the photograph you saw before. And then it would feed into Lake Michigan. The problem was that the north branch, being heavily polluted, would basically pollute the drinking source, which is from a treatment works just around about here. And so it's polluting their own backyard. So what they actually did 100 years ago was actually reversed the south branch. And you can see this nice long straight section is actually Park Canal. And they actually, now the water flows down the north branch. They actually let water out of Lake Michigan. And then it combines and flows down here to the Mississippi. And it actually ends up in the Gulf of Mexico. So it's quite a major engineering feat, all to get over pollution. So what we've done is we've actually put 3 Proteus units, one on the north branch, one on the south, and one on the main stem. And the great thing about this project is the 3 probes help to self-validate each other. So you can always, it's a bit like an equation. So if you get a high level of pollution down the north and a low level coming down the main stem, which you'd expect, then you'd expect to see something in the middle on the south branch. So it's almost a perfect experiment. All three are live. Again, they are during the bathing water season. They're solar powered. They upload every 15 minutes to public platform, and they have a calibration every 6 months. This is actually just a quick video to explain it, and this video is really summarizes the situation world over, what the problem is, and how potentially how easy it is to resolve. So,
and what a beautiful afternoon to be live on the river. And the Chicago River, we all know the story, right? Turn of the century, turn of the 20th century. Flow is reversed to keep the sewage from the city from getting out into the cribs and into the drinking water. Problem solved, right? Well, not quite, but we're getting pretty close. Let's check out a new tool that we're using. It's always nice to know before you go, and a new tool, H2 Now, provides just that. Knowledge about the fecal content of the Chicago River for folks who want to spend some time on it. And yes, you heard that right.
We care about fecal coliform. Like, why do we care about poop in the river? It's not because it's actually inherently hazardous to people. It's because it's often an indicator that there's other bacteria and viruses in the river that we might be more concerned about. And so that's why we're testing this novel sensor.
The truth is, this isn't something unique to just the Chicago River. Fecal coliform is put into every river by both animals and humans, and occasionally worsened by severe weather.
Extreme rain events can lead to something called combined sewer overflows. When those happen, there's actually sewage that goes into the river. When that happens, you do want to exercise high caution and stay away from the river for a period of a couple of days till things settle down.
In the past, the way the data was collected was someone to have to come down here, physically sample the water, then send it out for analysis. And while you're waiting, just a stray rainstorm could drastically alter the chemistry of the water. Now you get that data in near real time.
What we need to be concerned about is the climate feature that's ahead of Chicago means more wet weather and more intense rainstorms. So our concern is really that the trajectory of those improvements might change, and we want to know what's happening in the river and be tracking it in real time so we can stay ahead of that.
And it's super simple to do, and the website interface is pretty slick. It's h2nowchicago.org. We put a link to it on our website as well as the story after we're done. And it's great. It's got a little dial on it. It shows you exactly where the level is. Every 15 minutes it's updated. A super way, thank you very much, to enjoy the river. Perhaps you're going to go on a tour like Chicago's Emerald Lady here, guys.
Okay, great. So this, just moving very quickly on, this is just an excerpt of some data, and the green line is obviously the actual main trend. You can clearly see peaks and troughs. You can not only see rainfall events and CSO spills, but you can also see dilutions as well from cleaner sources. It's very instant. It shows you very, very quickly. You can easily apply thresholds to any of this data. So if it goes over a very specific threshold, then it can send all sorts of alerts out to whoever you might be, and they would literally get it seconds later. And I think that is it. Oh, sorry, it's just really just to sort of summarize on that. You can see that the rain of events can cause the fecal coliform spikes. And obviously there's the CSO spikes, the tributaries, and the great thing about this platform is that because we use fluorescence being an optical sensor, we don't have to rely on what's called ion selective electrodes, and the most classic one of it's used routinely on rivers is ammonia. And the problem with ammonia is that the readings drift very, very quickly, so it's extremely high maintenance. And so cannot be used as a long-term reliable tool en masse without maintenance. So whereas the Proteus being optical, you could put it in the water for at least 6 months and not worry about it drifting. And I think that concludes the end of this webinar. So we're probably a little bit behind, but we would like to open the chat up for any questions. I'm not sure if there have been any. I can't access it whilst I'm talking. So Hannah, have you seen any?
Not as of yet, no.
Okay. We'll hang around for a few minutes anyway. But if anyone's got any questions, by all means, please, we'll hang around. Obviously the webinar, as I said, we'll make that live. I expect that will probably be live by Monday, so you can all access it and watch it in your own time. But
I'm not sure, Rob, if we're having a slight technical issue. Someone's got their hand up, but I don't know if the chat's available for people to write in.
Is it Raphael? Yeah, I think we are having a technical. I'm not sure if the chats for some reason is working.
Right, you might be able to some of the guests might now be able to unmute.
Still muted.
I can make a presenter. That's about it. Hang on. See what happens. Raphael?
Yes, hi, can you hear me now?
Yes, I can hear you, yes. Hi, nice. Thanks for joining us today.
Yeah, so I'm Raphael, I'm the CEO of Nijhuis Environment. We're starting a few water monitoring projects in southern Italy. Last year we had some exchanges with someone from Proteus, but unfortunately we still didn't secure the financing to start up. But I wanted to have some comments maybe on the operational costs. So to give us an idea of what would be the investment for a potential client, for example, for the continuous monitoring using a buoyancy system on the coastline, just to understand if it's something that it's implementable in Italy as well on the Italian market, or if it's still too expensive to access, let's say,
Sure.
more the Mediterranean area.
Yeah, it's a good question. I mean, once the system and is purchased and it's deployed, it does depend on the sensors. We would typically recommend a once a quarter visit to them. Many of the sensors are optical and very, very stable. So it's more of a checkup than anything, but the likes of something like pH, in many respects, from a maintenance point of view, is probably not much different to a lot of other pH sensors out there. But we would probably recommend about every 3 months. In terms of the parameters, the sensors that would measure coliforms, then you can certainly extend that out, and you could be looking anywhere between 6 and 12 months between having to do a calibration on those sensors. In terms of running costs, apart from calibration fluids and be able to get out there and to the actual device, very little. There are no replacement parts apart from possibly some wipers and brushes, but they're pennies or dimes or whatever you might want to reference it in. But yeah, very inexpensive. There are no replacement sensor parts that you would need to buy.
Okay, thank you. So basically the purchasing cost for us, and then what would be billing the client, we have to consider every 3 or 6 months for the maintenance. Just another small question. A lot of let's say objections I had when I tried to propose this kind of service is that the law establishes very precise monitoring, let's say, methodologies, and I am afraid that we couldn't get the same validity of data from the Proteus compared to the standard methodology of single point sampling and then analysis in the lab. So I'm wondering if you managed to overcome this issue in the UK or in the US.
No, we're not really here to try and reverse legislation or protocols for doing this. we basically are tackling this from a different angle. You know, you have one reading a week versus one per second potentially, and the good that can come from real time or very rapid measurement of the likes of E. coli, even if it wasn't absolutely perfectly accurate, will provide a massive step change in how you can protect areas. You know, taking one sample a week, and let's be honest, samples will be done during daylight hours. They'll be done quite often. It will be at the same time each week by the same person. So it in many respects, sampling is flawed. But what is not really publicised is that sampling to laboratory has lots of different points of error introduction, and you don't see those errors. They're not obvious, but it can be very simple things like whether your sampling equipment is perfectly clean, whether you're taking it from the right place, do you chill the samples, how long does it take to get to the laboratory, did the laboratory analyze it accurately. You know, the method of accuracy is typically stated based on only the lab process. It doesn't take into account all the errors that can occur beforehand. So once you've added all that up, which is impossible to quantify, the advantage of a Proteus should be far outweigh manual sampling.
Can I just add a little point, Rob?
Yeah, sure.
Just going on to that, filling in the data between the cracks. I think that's a really strong point, because in terms of dropping quality, quite often most of the things of greatest concern occur in the minority of time. So whether it's a storm event or whether it's a spill, trying to understand processes in terms of what's going on, it's all about data. And the problem is the weekly data set, when you want to try and model it, when you want to try and build up discounting models for trying to inform the public and understand what's going on, if you're only getting one data point a week, and generally that's on dry weather conditions, it takes a very, very long time to be able to gather that data around it. So to be able to have sort of semi-quantitative data that can really fill in those holes around tide, around events, can basically better inform the models we have and to target the limited budget for analytical work. So I think this is complementary rather than trying to replace. That was all I was going to say.
Yeah, and it is very disruptive. You know, it's very different to what everyone's used to. So there's obviously going to be an element of change, whether people want to change, whether they, you know, they obviously like to see evidence. And so one of the things that we did when we came to market with all of this is that we wrote scientific papers, because obviously the revelation of being able to measure something like BOD or coliforms, it needs to be underpinned by science. And we don't want to spend the next 30 years having to do demonstrations to everybody. So it's important for everybody to see the scientific data. And it's great, you know, little projects like what Andy and Jack have shown to show you how it works. Hopefully that's answered your questions, but we're obviously here, so we've got plenty more question time. If you want to send us an email and we can respond. I'm just seeing there's a few more questions coming through on the chat now. So Paul has mentioned that the use of EDMs is increasing in the UK. Yes, so I think we're over 90% installed now, but are they being used and installed properly? Not a question I'm going to be able to answer comprehensively, but yes, you know, an instrument is only as good as the person who's installed it. So if it's not installed correctly, it's going to give bad data. But as I said before, EDMs don't necessarily, and in the defense of water companies, don't necessarily mean that there is pollution. However, they can obviously go the other way, that it can mean pollution, but all they tell you is duration, not quality or quantity. So with the Environment Bill last year about measuring upstream and downstream of CSOs, that will start looking at quality, and I think there will be some very rapid developments once that program gets started. Pablo asked what parameters you need to measure E. coli. Right, typically we would use turbidity and temperature because we need those for correction purposes along with tryptophan. And if it is a very clean environment, we would recommend the use of CDOM as well. Other than that, you won't need anything else. They're all optical sensors. So again, maintenance is really at the 6-month level. Oh, sorry, Hannah, you've answered it. Okay, great. Just looking at the next question there. That's a good question, Duncan. Has there been any examples of the monitoring data being used in real-time calibration of reach-based water quality modelling? Yeah, it's all really very early stages for all of this. Certainly, I know that the data for Chicago is being fed into a huge database for AI learning purposes as well, to understand what else might be happening. But I'm not aware of anything else in the UK. Obviously, we're sort of first to market with all of this, so it's all very now, I'm afraid. I think that's everything. So thanks for everyone who's come. It's been great talking to you, and we're obviously here, and we'll share the presentation, and you can obviously approach any of us after the presentation if you need any more information. Okay. Just lastly, the last of the 3 webinars is going to be on the 9th of June, and it's going to be based on wastewater treatment works. So that will be from inlet to outlet. Okay. Thanks very much, guys, and have a good afternoon or evening or very early morning, depending where you are. All right, take care, guys. Bye.
Thanks, everyone. Bye-bye.
Cheers.
Thank you.